This is section 11.3, Geometric Sequences and Series. Our objective today is I can evaluate a geometric sequence and I can evaluate a geometric series. Looking at what our variables are going to represent in our equation, a sub 1 is still going to represent the first term, just like it did with arithmetic sequences and series. D is going to be replaced with R. And R in this case is the common ratio. So instead of D, which is how much we're adding, the common ratio is just how much we're multiplying by. N is still going to represent a number or a term. And then A sub n is going to be the value of that term. So if I say what is the value of the fifth term, N is going to be 5, and you're going to be solving for A sub n. For any geometric sequence in which the first term is A sub 1 and the common ratio is R, we can find the nth term, also called A sub n, using the following formula. So this is the formula we're going to be using for all of our equations. And like the arithmetic sequence and series formulas, you do not have to memorize any of these formulas. You will be given them on any quiz or test. Julian hears a song by a new band. He emails a link for the band's website to 5 of his friends. They each forward the link to 5 of their friends. The link is forwarded again following the same pattern. If the pattern continues, how many emails will be sent in the 8th round? So we want to go ahead and we want to start with our formula, and we want to see, okay, what do we know? Well, we know that A sub 1, on the first round, Julian is sending out 5 emails. And then they each forward that link to 5 of their friends. So we know that those 5 people are sending it to 5 more people. So we're multiplying by 5. So in this case, R is also 5. The link is forwarded again following the same pattern. If the pattern continues, how many emails will be sent in the 8th round? So we know that N is going to be 8 because they want to know the 8th round. So let's go ahead and solve this. A sub n, we know, is going to be A sub 8 because we want to know the amount in the 8th round. A sub 1 is 5, R is 5, and N is 8. So now that we've plugged everything in, 8 minus 1 gives us 7. And remember, we want to do our exponent first for the order of operations. So we want to do 5 to the 7th power. And that's going to give us 78,125. And we want to multiply that by 5, which is going to give us 390,625. And that's going to be our final answer. And in this case, we are talking about emails. In example 2, we're writing an equation for the nth term. So in these equations, remember, we always want to leave n how it is, since this is just a general rule. So here, we know that A sub 1 is equal to 0.5, and we want to find out what R is equal to. So what is that common ratio that we're multiplying by? And if we take 0.5 and multiply by 4, that's going to give us 2. 2 times 4 will give us 8. 8 times 4 will give us 32. So R, our common ratio, is 4 in this case. So when we write our equation, we're going to have A sub n is equal to 0.5 times 4 to the power of n minus 1. And we can't do any simplifying here because if we multiplied the 0.5 and the 4, we would not be going in the order of operations. We have to do the exponent first. So in this case, this is our final answer. A sub n equals 0.5 times 4 to the power of n minus 1. In the second problem, problem B, they gave us A sub 4 equals 5, so we have to use that information. So since A sub 4 equals 5, we're going to say 5 is equal to, we don't know what A sub 1 is, so we have to leave it as A sub 1, R, which is 6, and then N, which is going to be 4 because they gave us A sub 4 minus 1. So we need to solve for a sub 1. So when we go to simplify, we have 6 to the power of 4 minus 1, which is 3. And if we take 6 and raise it to the third power, that's going to give us 216. So then I need to divide by 216. And that's going to give me a sub 1 is equal to 5 over 216. So now I need to plug those in to write the general rule. So I'm going to have a sub n equals a sub 1, which is 5 over 216, times r, which is 6, raised to the power of n minus 1. And that's going to be our final answer. Like arithmetic means, geometric means are the terms between two non-consecutive terms of a geometric sequence. We can use the common ratio r to find these numbers. So this is very similar to what we did with arithmetic means. And I'm just going to write this out, how we saw it with arithmetic means, so you can see what this looks like. This says find 3 geometric means, which means we're going to have 3 that we don't know, or 3 question marks, between 2 and 1,250. So we know that 2 is a sub 1, and we know that our fifth term, a sub 5, is equal to 1,250. So we're going to take that information that we know, and we're going to find r. So we're going to have 1,250 equals 2 times r, which we're not sure what r is, all to the power of n, which is 5 minus 1. So we're simplifying this. I'm going to have 1,250 equals 2 times r to the 4th power. I'm going to divide both sides by 2. So taking 1,250 divided by 2, I'm going to get 625 is equal to r to the 4th power. Solving for r, I'm going to take the 4th root. And if I take the 4th root of 625, I'm going to get 5. So, keep in mind they didn't ask us for r, but we're going to use r to find the next terms. So r is what we're multiplying by each time. So 2 times 5 is 10. 10 times 5 is 50. 50 times 5 is 250. And then I can always go ahead and check. We only had 3 question marks, so these are the numbers that I need. But if I take 250 and multiply by 5, that is going to give me 1,250. So we know that our answer is correct. So in this case, our answer is 10, 50, and 250. In example 4, we're looking at sums of geometric series. And they want us to refer back to example 1 and look at, if the pattern continues, what is the total number of emails sent in the 8 rounds? So as you can see, I've copied the information over from that slide that we had from that first example. So we have a sub 1 is 5, r is 5, and n is equal to 8. And looking at our two formulas here, we can see that if we use the first formula, we need a sub 1 and a sub n. And if we use the second formula, we need a sub 1 and n. And in this case, we already have a sub 1 and n, so we're going to use the second formula. So we have s sub n is equal to a sub 1, which is 5, times 1 minus r, which is 5, to the nth power, which is 8, all over 1 minus r, which is 5. So now I can go ahead and evaluate this. 5 to the 8th power is going to give me 390,625. And then 1 minus 5 is negative 4. So if I take 1 minus 390,625, I'm going to end up with 5 times negative 300,624. All over negative 4. So if I multiply by 5 and divide by negative 4, my answer is 488,280. And these are emails. And that's going to be our final answer. So this is really just about taking our numbers, plugging them in, and solving. We can go ahead and look at sigma notation, and again, just like with the arithmetic, the bottom is going to be our starting point, the top will be our stopping point, and then whatever they give us to the right of our sigma is going to be the function that we use. And again, they tell us how to find a sub 1, how to find a sub n, how to find n, and how to find r. So I went ahead and copied the two formulas that we can possibly use over to the right. And we're going to go ahead and figure out which one we want to use. It doesn't really matter which one we use. We'll just go ahead and use the second one on this one. It doesn't really matter which one you use though, because it tells us how to find each of the numbers. So for this one, we need to find, since we're using the second formula, we need to find a sub 1, which is found by plugging in the bottom number. So our bottom number in this case is k is equal to 3. So we're going to have 4 times 2 to the power of 3 minus 1 to get a sub 1. We're also going to need r, which is the base being taken to a power. So all you need to do is look over here and see what is actually raised to the power of k minus 1. And in this case, it's 2. So r is going to be equal to 2. And then we also need n. And to get n, it says the top number minus the bottom number plus 1. So we're going to have 10 minus 3 plus 1. So we need to go ahead and evaluate a sub 1. So 3 minus 1 is 2, and 2 squared is going to give us 4. 4 times 4 will give us 16. So a sub 1 is 16. 10 minus 3 is going to give us 7, and then 7 plus 1 is going to give us 8 for our value of n. So now we can go ahead and plug all of these in. So we have s sub n is equal to a sub 1, which is 16, times 1 minus r to the power of n, so 2 to the 8th power, all over 1 minus 2. So if I go ahead and take 2 to the 8th power, that's going to give me 256. And 1 minus 2 in the denominator is going to give me negative 1. 1 minus 256 times 16 is going to be equal to negative 4,080. And then we want to divide by that negative 1. And so our final answer is 4,080. In our last problem, they want us to find a sub 1 in the geometric series where s sub n is 13,116, n is 7, and r is 3. Now, since they gave us n and r, and they want us to find a sub 1, the best formula to use is the second formula because that's the one that has the information that they actually gave us. So let's go ahead and plug in what they gave us. We have 1,000 or 13,116 is equal to a sub 1, which we don't know what that is yet, times 1 minus r, which is 3, to the power of n, which is 7, all over 1 minus r, which is 3. So now we can go ahead and solve. So if I take 3 to the 7th power, that's going to give me 1 minus 2,187 all over 1 minus 3 is negative 2. I'm going to go ahead and multiply both sides by negative 2. And that's going to give me negative 26,232, which is equal to a times, and 1 minus 2,187 is going to give me negative 2,186. So now I can go ahead and divide both sides by that negative 2,186. And that's going to give me what a sub 1 is equal to. So in this case, a sub 1 is equal to 12, which is our final answer.